Hey, hello, and welcome to today's GFG problem of the day, intersection of two sorted linked lists. So let's see what the problem has to say. Given two linked lists sorted in increasing order, create a new linked list representing the intersection of the two linked lists. The new linked list should be made without changing the original list. Okay. So the elements of the linked list are not necessarily distinct. So what the problem is trying to say is, if you see this example, right? 1, 2, 3, 4, 6, linked list 1, and the linked list 2 contains 2, 4, 6, 8. So we want to create a new list containing the common elements from both these lists. Basically, say 2, 4, and 6. 2, 4, and 6. You have to create a new list with the common elements from both the list and return the new list, right? So you have to take an extra space, right? We have to create a new list without modifying these two linked lists. Okay. So what we need to do, right? Simply we'll iterate through these linked list and create, right? Create new linked list. Okay. So it's a pretty simple problem. Let's try to write the code and understand. Okay. For example, let's say, okay, let's take a new list, new first node, right? New head, right? Equal to new node, and we can take any value, any zero, for example, right? Let's take a zero example. And what will take? One iterator will take node temp equal to new head, right? This iterator is for this new list. Okay. And what we'll do, let's write the code. Well, head one is this linked list 1, right? Is head 1 of linked list 1 is not equal to null. We have to iterate, right? Head 2 is not equal to null, right? And then simply what we'll do, if we find a common element is, sorry, dot data, head 1 dot data equal to head 2 dot data, right? If we find two nodes with the same value, then simply what we'll do, temp now contains, sorry, okay, now temp currently is pointing to what? 0, right? Temp, right? So what we'll do, temp, right? Temp, okay, yeah, temp dot next will take, temp dot next equal to new node will take, right? New node, and head 1 dot data, anything we can take, right? Head 1 dot data. So for example, in this case, if 2 is matching, right? 2 is matching. Then what we'll do, we'll create a new node, right? And we'll point to this temp dot next. Temp dot next equal to 2. New node we have created, right? And what we'll simply do, temp equal to temp dot next. We are moving temp now, right? And we'll also, head 1 also will move. Head 1 equal to head 1 dot next, right? And head 2 equal to head 2 dot next, right? This is for if the values of the two nodes are matching. Else if, right? Else if, for example, head 1 dot data. In this case, right? In this case, what is the example? Let's take it over here. Let's write it over here. Right? 1, 2, then 3, 4, 6. Right? 3, 4, 6, and 2, 4, 6, 8. 2, 4, 6, 8. Right? So yes, so what, so consider this case, right? First, head 1 is pointing here and head 2 is pointing here. Head 1 dot data, if it is less than, head 2 dot data, right? If it is less than head 2 dot data, then simply move head 1 ahead. Why? Because we want to check for the same elements, for the common elements, head 2 dot data. Sorry, next. next, right? We are moving head 1 next, right? Else, head 2, head two's data is less than head 1, right? So we have to move head 2 dot next. Okay. So, yeah. So, yeah, in this case, we'll move here, right? Head 1 will move here first, right? Head 1 will move here, right? And then, and head 2 is here. For example, head 2 is here, right? And head 1 is here. We have moved head 1 over here, right? And then when we come again, we'll check here. We will check, right? We'll check if head 1 equal to head 2. If it is, then we are creating a new node. We are moving temp here, right? Temp. We are moving temp here, and we are moving head 1 and head 2 as well, right? So head 1 will point here now, and head 2 will point here. Head 2 will point here now. Okay. And then again, we'll check. Next, we'll come here. We'll check head 1 dot data is less than head 2. We'll increment head 1 again. We'll increment head 1 again. So we'll move head 1 here, right? And then again we'll come over here in the first if loop. This will match again, head 1 equal to head 2. 4, 4 will match again. We'll create a new pointer. This is temp. We'll create a new node 4, right? And then we'll simply, once create a new node, we'll simply move the temp ahead, right? Temp ahead, right? And then head 1 and head 2 as well. Head 1 and head 2 as well, right? This is head 2, this is head 1, right? And again, we'll come here, this 2 will match, and we'll create a new node, 6, right? It will be temp, right? And then we will increment head 1 and head 2 as well, right? Head 2 as well. So head 1 has reached the end, head 2 will be here, head 2. So head 1 has reached the end, right? So henceforth we cannot find any more common elements between the two lists, right? So what simply we'll do, we'll return new head, right? New head dot next. Why new head dot next? Because new head is pointing here on this temp, right? New head is pointing here. New head is pointing here, which is a dummy element, right? You have to return the next element, the pointer from the next element from here, right? That is one new head dot next. New head dot next here, right? New head dot next here. Yes. So if you see, yeah, we had created new head, new node, right? And then we had simply, uh, uh, yeah, simply we had copied the pointer to temp, and temp was the iterator basically, right? So that is why we had written new head dot next. Okay. So if you see, I have already implemented the same thing over here, right? So we are adhering to the space and time complexity, right? Space complexity is extra of n plus m. If you see, in each, whenever the head 1 and head 2 matches, data matches, we are creating a new node. We are taking extra space, right? And we are also adhering to the O of nm time complexity. We are iterating both the lists, right? So yeah, let's submit. Okay, the solution is accepted. Thanks for watching. Please like the video and subscribe to my channel. Thank you so much.